this window pops up, and you can then say, okay, I want this is my target cell to minimize. I want it to be minimum by changing what? Changing C1 and C2, C1 and C2, these two cells. So basically, I'm asking the software to change these two values so that I get a minimum value there. Right? Okay, let's do it. And you just click solve. So the answer I get 0.0765. Oh, let's see if it's the same. Where is it now? (0.07435), 5.26, about there. Yeah. Okay, let me see. Okay, so as you can see, something that I took about a month to solve, now I can solve it in less than 5 minutes using technology. So that's the power of technology, and I think in terms of mathematical modeling, very often we have to use some form of technology to help us bridge the gap sometimes. Okay, let me move on. I realized that when I look back and reflect, I was actually going through the well-known mathematical modeling process without actually knowing it, without actually knowing that I was going through the process. As you can see, I looked at a real-life problem, which is to model blood flow in elastic arteries, and then there was some kind of mathematization, solving some problems and trying to refine it. I didn't go to the details, but there was a lot of refinement going on, and then comparing with data and checking, interpreting, then into reflecting and so on, and getting back to the real problem and interpreting the results and so on. Now, and it just happened quite naturally. I realized only recently that there's actually there is no need to be so obsessed with or preoccupied with this kind of a diagram, and we can use it as a guide. But I think modeling can be a very natural process, yeah, in itself. So the next question is, can we actually teach mathematical modeling? Well, I think the speakers this morning have already said yes, yeah, but and some people believe that it cannot be really taught, but more caught than taught. Many teachers and students do not feel very comfortable with this idea of mathematical modeling, especially in Singapore. And here are some reasons why. We're not comfortable because we feel that there's no unique solution. Problem is often very open-ended. You don't know where to begin. You don't know when to end. Requires skills or knowledge from different topics of mathematics and sometimes different disciplines. The emphasis is on the process, you heard this morning as well, rather than the product. So people feel a little bit comfortable, a little bit uncomfortable with that. There's no standard instrument for assessment. You have to look at everything, not just the end product. And very often it takes it takes time, days, weeks, or months to solve the problem, and sometimes you don't even get close to solving any problem. Yeah. So these are the reasons why some people may feel, students as well as teachers may feel rather uncomfortable, at least in Singapore, with mathematical modeling. But despite all these reasons, I feel that mathematical modeling can still provide a very rich learning environment, okay, for the same set of reasons. Right? It is precisely because there's no unique answer, very open-ended, requires interdisciplinary skills and knowledge, emphasis on process. Different ways of assessment, and because it takes a long time, that something like mathematical modeling provides a very rich learning environment for students of mathematics. Now, this is a clear illustration that sometimes in life we can view challenges as problems, or we can see them as opportunities. The question now is, in this case, how can we seize the opportunities and what can we do? I'm talking more about our local school situation now. So can we can we then teach math or learn mathematical modeling? Now this is how I see it. Now suppose, now let me just draw an analogy between the teaching and learning of mathematical modeling and the teaching and learning of mathematical proofs. I think in this country, many teachers will know, or at least believe they know what to do when asked to teach proofs. We will discuss methods of proofs, proof techniques. We are able to set proof type of items and so on. But in reality, when we are doing things like that, are we proving anything? Or are we just practicing techniques of proof? We are not really proving anything that we don't already know, right? For example, if we were to teach, say, the proof that the square root of 2 is irrational, using contradiction, for example, we are not really proving that root 2 is irrational because we already know that root 2 is irrational, but we're just going through the process of proving. We are learning the technique of proof by contradiction, right? So, and yet we are happy to say that we are teaching mathematical proofs. So I see it this way. At the highest level in terms of proofs, if you want to really prove something, you have to have new conjecture, maybe you have a new kind of proof, and then you end up with a new theorem or something like that. That's what research mathematicians would do. But at the school level, are we expecting our students to do all that? I don't think so. At the school level, when we are teaching proofs, we are actually just practicing proving. We are proving old theorems. But there is value in learning these techniques because someday these techniques can be used for those things. Okay? So we teach and practice proof techniques, but we recognize that, there's value in doing so. Now, similarly, in mathematical modeling, we can think of it in a similar way. At the highest level, research mathematicians construct models to solve real-world problems, whether it's weather forecasting or sending somebody to the moon or Mars, and so on. And they collect enormous amount of data to validate, test their models, and so on. But at the school level, do we expect really original model, real validation and test, or do we expect real new problems to be solved by school kids? I don't think so. So at the school level, when we're talking about teaching of modeling, we simply provide experience for modeling, the process. We can solve old models, existing models, study them, and go through the same process just to learn how mathematicians have have tried and perhaps come up with those models. And we know that there is value in learning existing models as well. So for instance, if you are talking about, let's say, Newton's law of cooling, it's old model, everybody knows it, yeah? But there are different ways of teaching it. You could just give the formula and that's it. That's the differential equation and that's it. Or you could get people, students, learners, and so on to go through the process of so-called discovery by experimentation and so on. So that's the process of modeling that we are talking about. There's no new model, there's nothing new, there's no new equation, but that's teaching modeling. So in the classroom, exactly what do we teach? Well, we can talk about skills and techniques in typical modeling tasks. We can talk about examining established or existing models. We can develop new models for existing problems or use existing models for new problems. Now, 2 days ago when Professor Graham Wake was here, he was talking about the water pollution problem. And the model that was used was a pair of differential equations. One equation refers to the rate at which the pollutants are added to the river, and the other equation was the a differential equation describing the rate at which oxygen is being added to the river or something like that. Yeah. So when I was there listening to him, I realized that that is very similar, very similar to a model for kidney dialysis machine. Because when you purify blood, you have to pump the blood through the machine, for example, if it is through a dialysis machine. And at the same time, you have a dialysate going through the machine, and by the process of osmosis, there's the exchange of materials through the membranes. So the kidney dialysis machine purifies the blood, but cleans up, basically takes away the toxins and the waste from the blood because the kidneys have failed. And in the same way, when you are talking about the model for water pollution in the river, you're trying to clean up the river by pumping oxygen into the river. So there's a lot of similarity there. So I went home and